Welcome, everyone. My name is Sat Dugal. I'm the Chief Marketing Officer of DataHub. And on behalf of all of us here at DataHub and the more than 13,000 people in our open source community, welcome. It's our privilege to host, such an impressive group of AI and data leaders from such an impressive group of companies at the first of such events where we are exploring the mystery and intrigue, I would say, of this dynamic of AI and data. It should be a fun session. I think we have some really interesting conversations. We have some amazing speakers, and so really looking forward to it. And I couldn't think of a better speaker to kind of lead us through this journey than Shirshanka Das, co-founder and chief technology officer of DataHub. I think it's fair to say that about 10 years ago at LinkedIn, when they were trying to solve for how to do GDPR compliance at LinkedIn scale, DataHub and what became the open source project was a lot of his brainchild and something that he has been working on ever since, both as a thought leader and a practitioner, building this concurrently with our community as well as with many of our customers. So it gives me great pleasure to welcome Shirshanka Das.
Thank you, Sat. My usual joke is that if I had hair, I would have lost it all as part of GDPR anyways. But I'm glad I didn't have any to begin with. So, well, welcome everyone. It's a great pleasure to kick off this event. When we started, we came up with this idea of AI and data walk into a bar, and it was kind of like a funny title that we came up with. And then we started thinking, yeah, what if AI and data were actually people and they walked into a bar? Would they talk to each other? Would they order the same drinks? Would they sit close to each other or very far from each other? And of course, we had a bunch of stories from our past lives where, AI technology didn't get along with data technology, or AI teams didn't get along with. So we made a lot of fun jokes, and we thought, what if we could actually bring a bunch of folks that are in the mix who are actually doing data and AI and ask them this question, like literally, this is a prompt: AI and data walk into a bar, complete the sentence. And I think there's a fun puzzle competition we're having. So please take the time to fill it out. It's interesting. There will be no LLM judges for this prompt. We will have humans, in fact, yourselves, voting in many cases. So that's the fun part. But let's talk about some serious stuff. AI and data, of course, have become like a thing that we talk about. Like, I don't know how many times I said data or AI in the last hour, probably hundreds, and hopefully each one of you did as well. And of course, when we think about us as humans, we forget ourselves. Like, we talk about AI and data, but humans are very important, and we have always needed data since the beginning of time. I mean, of course, after fire, water, and some other things, but very soon we started needing data, and most of our needs were based on, as data consumers, I want to understand, where's the data? How can I use it? Is it trustworthy? Or maybe as a data producer, we talk about humans starting to figure out, can I deprecate this column, or can I actually delete this data set, and who am I going to impact, and things like that. And of course, there's a bunch of governance folks here, and governance people have always had a tough time with data because they worry about whether data is getting used in the right way and whether it is being used by humans in the wrong way and things like that. So of course, we as humans have always needed data, but turns out AI also needs data. Whether it's an AI model that's trying to make sure that data is fresh, up to date, and correct, or whether it is an AI agent that's trying to make sure that the prompt that it is responding to is using the right data, or a model that has been fine-tuned, whether it used the right data or was fine-tuned with an up-to-date data set. Those are needs that AI has from data. And flipping it around, data has a lot of needs from AI as well. I mean, in the past, of course, we were all writing out documentation manually and managing data in a lot more manual way. And now we're seeing this promise that AI can do so much for data management. AI could write docs for us. AI could classify data for us. AI could autonomously delete or retire data sets and just let us know later on that it did the right thing by leaving behind the right data as breadcrumbs. And of course, we see that AI and data together make for a pretty good combination, whether it is responsible AI. I'm trying to assert that a certain model that is in production has never been tainted by data from another customer. Guess what? You need to understand AI and data as participants in a global graph. And if you don't do that, then you kind of miss a lot of the magic that you can create, whether it is for understanding or whether it is for proving quality or compliance. So, long story short, we think AI and data deserve to belong together, and they're probably cozying up and having a good time inside the bar. But how? How do they talk? What drinks do they order? It's an important question. And of course, we feel like there's probably a maze that AI and data can get lost in, but they have the right metadata, then they can definitely find each other. So that was kind of the lead up to AI and data walk into a bar. Why is it interesting? We think metadata is the key, and hopefully every one of you do. We've kind of had a lot of conversations in the last hour, and I think we're all kind of secretly metadata enthusiasts, even though we are all either in the AI camp or the data camp. So a lot of this stuff is actually playing out. And a lot of you have had so many conversations today are actually making AI and data work together in amazing ways. For example, Square or Block, as they're called, I don't know why people change brands, but you now have to talk about the same company twice. But Square or Block, they kind of presented in our town hall recently, but they have managed to make AI and data talk to each other. And how do they do that? Well, Block has a large and complex data ecosystem. It probably looks very familiar to stuff that you have in your stack, or maybe less complex. But anyways, they kind of have orchestration systems, transformation systems, et cetera. And they used DataHub Cloud to kind of bring all of that together, a single graph, end-to-end lineage, search results ranked by popularity, being able to do data domains and products, all the good stuff that happens when you bring everything together for humans. But then they realized that that wasn't enough. They had a continuous set of questions that they needed to keep answering. We need to bring costs under control. We need to understand observability or access control, and machine learning assets have to be part of it. And they realized that while they were busy integrating all of these assets into the graph, a lot of the day-to-day workflows that they needed to accomplish could be done using AI agents. Because a lot of times you are waiting for someone to go in and work with all of this metadata or context to understand what needs to be done next. What if AI agents could actually simplify a lot of this complexity? So they got started. It was something that happened organically because Block at that time was starting to collaborate with Anthropic on the MCP spec. MCP, of course, everyone knows now as Model Context Protocol. DataHub actually invented MCP first. We called it the Metadata Change Proposal. That was our initial language. But of course, now we are going with the flow and calling Anthropic's Model Context Protocol as the MCP spec. So I hope you all know that Block invented or created an AI agent called Goose. It's Jack Dorsey's personal project. He cares a lot about this. And so every employee at Block actually has Goose on their laptop. Like it literally runs on their laptop. And so they had been working on Goose, and they were starting to automate a lot of operations that they did across the enterprise. And then they realized, wait a minute, we have a lot of interesting information locked up behind DataHub. And every once in a while, we have a data incident or a privacy incident or a quality incident, and we have to do a resolution of that incident. We have to find who is responsible. We have to traverse the lineage graph. We have to find who's impacted. We have to bring everyone together into a Slack channel. What if we could actually have an agent kind of facilitate doing all of that? And so then they started talking to us, and we collaborated with them and built an MCP server for DataHub. And it was pretty interesting to watch how that came together. And so now, essentially, DataHub supports Model Context Protocol that allows any agent, whether it's Claude Desktop or Cursor or Goose in this case, to talk to DataHub and interrogate it and ask it interesting questions, and in the future also do interesting things with it. Who better to kind of lead us through that than actually the Block team themselves? They actually presented at our town hall, so I'll just play the demo really quick. This is essentially the data engineer at Block demonstrating how they are running incident resolution using DataHub and Goose together. So Goose is the terminal that you'll see on the screen, and it's the agent that's interrogating and.
So let's say I'm an engineer investigating a data incident. There's a Snowflake table called all hammers, and I need to find that table in DataHub. And first I need to verify if it's the right one, because there might be many with kind of slightly different names. But once I find the right one, I need to look upstream and find some data owners of upstream assets and then figure out how to contact them via email or Slack or whatever, PagerDuty, so that I can pull them into this incident and help them or get them to help us investigate. And so first what it's going to do is it's going to search DataHub for data set entities using the all hammers search term. It found a URN. Then it's going to get the data set info. Once it does, it'll print out some information about it. So this one's got some important tags. This looks like the right table. And so I'll say, yeah, that's the right one.
And so, it continues. I didn't want to bore you all, but basically the idea is you've got an agent that's essentially conversational, and you can get it to go across your organizational data. In this case, it was actually querying their HR data as a separate data source, working through ownership and groups and managers through that interface, but then also joining it with data that was in DataHub and working through the lineage to really do end-to-end incident resolution. So that's cool. And then, of course, we ended up using that same integration and the same interface to enable Claude Desktop and Cursor and other systems to talk to DataHub. And also that is the foundation for the Slack interface that is in DataHub Cloud. So essentially you can talk to DataHub pretty much like.
I can at DataHub, I can say I'm planning on changing the color column, look at what things will be impacted. Here, if we look at the thread, I'll be able to see it kind of thinking and searching through our backend. And then it will be able to write up a response here. So now we can take a look at the response. It tells me what is directly impacted by this, as well as a couple tables that are, 2 hops away and might be impacted. And basically traverse the lineage.
So this particular example was someone's changing a column, happens all the time, and trying to figure out, will the change in this column semantics, it's not as simple as just dropping, but will a change in the column semantics actually impact, and who will it impact? And so obviously it sounds simple on the surface, but it requires navigating not only lineage, but understanding the transformations, understanding which of the transformation use that specific value in the column. So as long as I'm expanding the list of column values, it's probably okay, and things like that. So doing that next level deep analysis that a human would normally do is now starting to become accessible, which is pretty exciting, I think, for the world of data debugging, data triaging, incident resolution. And so I honestly was blown away the first time we put the software together and then started interrogating the graph. And it's been quite interesting to see how much the LLMs are able to actually intuit based on the information that's in the graph. So that was an example of productivity, or making humans a lot more productive through the power of AI connected up to data or metadata. Second example here is about AI and data kind of relying on each other. So I talked a lot about how quality is important. And this is something that I heard bits and pieces of during the evening. We talked a lot about observability. And I heard 2 terms, data observability. I also heard AI observability. I also heard different teams doing data observability and different teams doing AI observability. And sometimes those teams don't talk to each other. And what we found with our company called Riskified, now Riskified, I don't know, do people know what Riskified does? Okay, so Riskified is a company that essentially offers an API for online e-commerce platforms, any financial transaction company, to essentially call that API to reduce their risk of fraud. They're essentially a online risk management company when it comes to transaction processing. So as you can imagine, real time is the name of the game for them. They're not all of their data, all of their processing is pretty much real time. And so they have a ton of features that they have built. So they are, we're talking classical ML or predictive ML, where they have a lot of real-time features that they build, and they use those features to rank or score a particular transaction in terms of risk. And that's the API that their end customers use. Now, obviously, in this business, for them, the quality of their risk score is the most important thing for them. They get rated on how much fraud they were able to prevent and how many legitimate transactions they were able to actually process, or false positive, false negative. So quality is super important for them. And as a result, the quality of the feature that they have in production is super important for them. And actually, unbeknownst to us, because we have enough customers right now that we often don't exactly know what all they're using us for. It's not that easy. So we found out that Riskified has been using us for essentially asserting quality of their real-time features, not just their data warehouse ML models or features like that. And so they have created the concept of feature contracts. So any data contract enthusiasts in the house, I know Jay is, but I'm sure a lot of you are, they've created the concept of feature contracts. And feature contracts are essentially definitions of quality constraints, just like data contracts are, for features. And so they create these feature contracts, they register them in DataHub, and that tells them what data is this feature supposed to use, what should the logic be, et cetera, et cetera. And their goal is to create end-to-end column-level lineage all the way from the API endpoint. And that's interesting for us data people, because we end up always focusing on the warehouse. And sometimes if we are very ambitious, we go upstream one hop to Kafka and we say, oh, we are so end-to-end. But these folks are really end-to-end. They're starting with their service API, talking about a single field that is being used by a feature. And they're literally tracing end-to-end lineage all the way from there to their Snowflake tables, all the computation and offline creation that happens, and then back online. So the Riskified lineage graph, of course, this is a redacted and transformed version. This is not the real one. But it actually has multiple hops in it, and it extends across asset data sets, tables, upstream Kafka topics, and also API endpoints, and then back out into features that are serving their online product. So if anyone here needs any other good case study for why data and AI should belong together and that quality should be managed in a holistic way, please talk to Riskified. They've done it, and they seem to be reaping the benefits of that. So we talked about productivity, we talked about quality. Let's talk about safety or compliance, like the last one. Why should we leave that out? So AI and data do need to trust each other. And we happen to have a customer who hasn't given us permission to use their name yet, but they are a leading design tool. They are used by the world's biggest companies to design their products. So they're used for designing their product design tool. And they initially adopted DataHub Cloud as a data discovery tool. Like a lot of folks, they initially start with humans. Humans need to discover data and AI and understand transformations. And they love it. But then they realized that they have a second problem that they could be solving with us. And that was this problem of ensuring that their generative AI applications are never leaking data that was trained from another customer. So essentially, this is a company who Apple is a customer of this company. So Apple is doing some of their most serious designs in this tool. And guess what? Samsung is also a customer of this company. So Samsung is also designing their next version of their mobile OS here. And so when you think about a generative AI application that has been trained and is starting to give recommendations for how you should, what kind of border radius you should set for your your widgets, you wouldn't want it to start recommending, Samsung's style to Apple. That would be pretty bad. And so this company really wanted to make sure that they were able to assert, stand up in front of their customers, not really regulators as much, but customers, and say, we can guarantee to you that we are never using data that was trained from another customer to power your models. And while it seems somewhat simple on the surface, the end-to-end lineage graph for this was, not 22 hops. but 15. And it's not, small, and it has to be versioned. You have multiple versions of models serving in the product. And they want to not only assert that this has not happened, they want to ensure that if in the future they're able to find a privacy incident, oh, we didn't realize we actually have cross-contamination here, how quickly are they able to resolve that incident? So they actually measure themselves on the time to resolution, not just the fact that they can assure someone that this has not happened. And that was another interesting next use case that we didn't anticipate. They kind of figured it out on their own. And then, of course, we enabled it to happen. But that's another example of AI and data kind of starting to work together and enabling essentially this kind of impact analysis capability, where I can say, I've got a poison data set. Please tell me who all is impacted. And for you to be able to not only see tables or people, but also systems that are serving in productions, including AI assets. So those are a few good stories, I guess. Of course, we only pick the good stories to talk about. So 3 good stories, one on productivity or getting AI and data to talk together, second on quality, and the third on compliance or safety. But there are many other stories that don't get told, and not all of them have happy endings. If we were to continue thinking about AI and data as a couple, they often have fights. They can actually get in trouble and not talk to each other for a long time and things like that. So we thought, who better to talk to us about some of these stories? What are the challenges and how often these fights or conflicts are resolved than 2 folks who've been in the trenches matchmaking AI and data for the last decade and more. So I'm very honored to call up to the podium Deepak Agarwal, Chief AI Officer at LinkedIn, and Nitin Sarma, Senior Engineering Manager and Head of Data Discovery, Governance and Experiences at Netflix. And I will shut up and just ask questions now. So please sit over here. And by the way, I don't know if Sat has already told you guys, but the completion, the prompt completion thing, please take it seriously. There's a really attractive gift at the other side of that. So I would definitely put on my thinking hat and try to come up with a good answer. So the way we thought about running this panel was really a few questions that we've thought about that would be interesting for the audience. And the rest of the questions are really what we want to get from you. So if you look at kind of your table, you'll see a little QR code where you can actually submit questions that you would like to have these folks take up. And once we go through our section, we'll kind of pull it up and start answering them. All right, so let's start with the first question. I'll start with you, Deepak, but generally the question is, when in your past life have AI and data, struggled to get along together? Please tell us how that happened and how you resolved those conflicts.
Yeah, I think it's, I've seen people anthropomorphize AI, but the fact that you've done the same with data, that's very interesting. So yes, they sometimes don't get along together just like as good couples, but they are a couple, right? And I can speak to that from my Bell Labs days, right? Like when I was at Bell Labs, you might have heard of a famous person, John Tukey. He's the one who invented the field of data science, right? Like look at box plot and all that stuff. So I have always thought of data and AI to be the same, in my opinion. Like AI is nothing but a transformation of data that you create, which is doing useful tasks, right? And so obviously they have to be thought through holistically. But as Shirshanka said, when you start scaling this, that's when the trouble begins, right? Like if you're doing a research project, it's not a problem, right? Like you can do a research study, write a paper, and if you're doing something like a very systematic study of clinical trial. I mean, that's one-time thing. That's where not the conflict happens. The conflict happens when you create something and then it is running in real production system, and then you have thousands of engineers building on top of that, and you cannot go to another person's desk and say, hey, can you tell me what the team, like this is when things just start breaking. That's where you need governance and metadata. So I mean, similar to your example, I still remember 3 years ago at Pinterest, I think there's someone at Pinterest. Yeah, Bala is there. We both struggled with this. So there are like hundreds of thousands of tables all created, and if someone wants to know the revenue information, like which table, which table to look at, was a huge problem. And similar to what you showed, I mean, back in those days, agents were not still there, but like that was the solution. Like and DataHub was one of the technology Pinterest used, but along with that, many other things, and created something we call PinCat. And then there was an SQL, and there was another program that was written to just even get you to the right table, right? And then once you get the right table, then you can do a lot of other things. But when you're running things in production, if this lineage and other things don't happen, I mean, there's been numerous times when the data that is running the model in production will break and will cost outages, right? I mean, this was a routine thing. And so I used to run an operations meeting every week just to kind of go through all the workflows that are running in the system, right? Like there are 150 workflows or more than that. Each of them is serving live traffic on the platform. Any one of those deteriorate, mean there is a material impact to the business, right? So that is how serious it gets when you're running a big business at scale. And oftentimes the errors were all due to data management, right? So it's too numerous to list, but every week I can tell you there were at least 2 or 3 such errors. When we started, it was like tens, and then over time it kind of reduced once we start learning from those lessons and improving things. So it's just hard work, right? But it has to be done if you really want AI to add ROI to the business. That's how important this is. Like, you can create an amazing AI model, but if you really want the AI model to add ROI to your business without managing the data and without making sure this couple is healthy, in a healthy relationship, business would not work very well.
Nitin, you want to add to that?
He's covered a broad surface of areas. 100% on the alignment between data and AI. One fun story that I can remember from Netflix several years ago was someone actually had a typo in the table that they were querying from and trained a ML model. Thankfully, that model no longer exists, but it turns out someone created a table with also a typo that had data in it. So it took us almost 90 days back and forth working with the teams of, this model should work. It's so basic. Why doesn't it work? Because the metrics offline show great. And it turns out we didn't have the metadata to say who's using this model. There was no lineage. There was no access control on this. And more importantly, we didn't even know that the table was never populated. So I think that began the journey for us several years ago of why metadata is the key, like Shirshanka and Deepak have been talking about. So.
Well, can you think about the scary thing that's going to happen now? Agents are going to be doing all of this.
Yeah, so, the fundamental piece is investment in metadata, especially with respect to business context, in terms of lineage, in terms of who's talking to your systems, and do they have access to the right set of data sets, the domain, the business units, all the way up to engineers who are actually operating on this. So this will not only empower the engineers to build and accelerate more often, it'll build you the traceability like you're talking about of, we know that we're operating on data and models that are absolutely critical for us. And if we are erroring, it's either we get observability right off the box of, yes, we're erroring, and people know on top of it. That's not the case in many situations over the last few years, but I do see that situation getting more and more with metadata investments going forward.
So, we talked about metadata a couple of times. And, every time I've tried to organize a panel, we do this thing called Metadata Summit. We've done it for 3 years. And the last time I think we called it Metadata and AI Summit. We always start with a foundational question. What is metadata? So back to you, Nitin.
Yeah. There's multiple categories of it depending on your business side of it. So we have like semantic metadata, where you just start having more context around what the usage is and how the data is getting used. You have partially, in some ways, business metadata, ownership, for example, like cost, ownership, where the data is coming from. Does it have sensitive information like PII? Should I be more careful about it? And then there is sometimes operational metadata, which is what's the schema for this? Does it align with what we were expecting to do? Between these three, there is plenty enough of coverage in terms of what should be put in and who's the gatekeeper of putting the data information in, so that we know that there is a shared, I would say, shared context between all the teams in terms of what metadata means. There's a sub part to that of how do we declare if something is a metadata or not. That keeps evolving. 5 or 6 years ago, the answer would have been schema is metadata. 3 years ago, oh no, the version that you're handling of the table is a metadata. Last year, the conversation was, of course, PII is a metadata. Right now, it's even one step further than that of if you're actually being used by a tier 1 service, that it is a metadata. So the definition keeps changing over time, and but it's pivotal for us to understand that shift is happening and that investments are made in that area.
So to the scientist in the house, what is metadata?
Yeah, I mean, the dictionary definition is, of course, it is data about your data, right? So, but that's not what we're looking. So in addition to what Nitin said, I think, as Nitin was saying, this is something that keeps evolving, and it should be based on your use case, right? Like, so you can add whatever you want in the metadata that will help you do your tasks. So just like any other things, like what are the fields and what is the information you need that's going to help you do the governance, right? Like, I don't think you should over-engineer it. Like, if you are using the data for a specific purpose, there's no reason to just add more than what you need. Like in the new world, I think the agentic world that we are moving in, I think the role of metadata has now moved to models, right? So the role of metadata also keeps moving upstream as the application layer that we are building keeps evolving, right? So in the new world of agent, we should think of metadata for AI models just as we used to think of metadata for data in the old days. If we don't do that, the agents would not work. And again, since these agents are making decisions, the ramifications would be way more severe than what we've seen in the past. Like I was talking about Ceph0 incident. Imagine Ceph0 incident happening when you're using the agent. Like that is going to be catastrophic, right? So the definition of metadata and the scope has increased enormously given where we are moving with the agentic world.
One thing that caught me by surprise, even though I have been in the metadata space for such a long time, was the realization that unstructured conversations about data are also metadata. And that's because context is really what matters. When a human is about to do something with AI or with data, or when an agent is about to access or process or transform a data set, what context do they need to actually perform that operation with confidence? So when you think about a discovery of activity, then conversations that have happened about this data set, or emails that are floating around in the ether, or a Confluence wiki page somewhere that's just pure text, is as important as a nicely documented technical schema. That was something that I hadn't truly appreciated, because at LinkedIn, for example, our world was very structured. And I mean that not from a structured data perspective, but also structured metadata perspective. We had literally Kafka schemas strongly typed for how you are supposed to report that a new data set had been shipped to production. But, that's not life. People are just sending messages nowadays and saying, please deploy this to production. That's the conversation. And so it's been interesting to watch as LLMs have kind of brought text and natural language back into the mainstream. The fact that that same text can now be interpreted as context and that can be translated back into machines has been kind of pretty interesting. Okay, so I think we went through a couple of pieces here. And one of the things that I wanted to ask you guys about is data governance has been a term that we've known for ages. And, this stays within the room, but it has never worked, right? Everyone can agree to that. But that's because data governance people are perfectionists. And it's not that it has never worked. It has just never worked enough for us to feel happy about where we are. But in more recent times, we've been talking a lot about responsible AI. So what do you think the overlap is between data governance and responsible AI? Are these different problems with the same spirit and should be done kind of differently? Or is there commonality between them at more than just the surface level?
Yeah, I think there is some commonality. So first of all, you cannot be responsible with AI if you're not responsible with data, right? Like one important component of responsible AI is PII. How do we deal with PII, private data? But responsible AI is a bit more beyond that. Like how do you make sure your models are not doing things, there are no unintended consequences like gender stereotyping and human right violation. So I think the main difference I would say is it is not deterministic. When you're doing responsible AI, your process is not deterministic, it's more stochastic. You cannot make the defect go to zero, but you can minimize the impact, right? And so that requires building a whole new muscle, right? When you're building software systems where the governance is not a deterministic set of rules that can be enforced, but it's more a stochastic entity. How do you even think about that, right? And then you have to also reason about governance and then business value, and there are trade-offs involved. So that's the new world we are living in. I think that would also come to data governance, because as Shirshanka was saying, we are moving in a world where unstructured is the norm, right? Like given how AI technology is working and given AI is now used even for data governance, unstructured would become a norm. And so the deterministic process that we have built is, I think that's probably, again, because I'm not traditionally a data person, I would say that is the reason why it didn't work. Because the desire to make it a completely deterministic process and yet have 100% coverage, that's actually very hard, right? And so it's better, in my opinion, to have some false positives, make the coverage better. And that's where I think you have to embrace this stochasticity that's coming into our world. And so that's where I think I would kind of take these two things, and they both need to evolve together. And at some point, I think there will be convergence.
So Nitin, as a purveyor of sharp tools in the industry, what do you think needs to happen at the infrastructure and tooling level to enable?
It's going to sound like a broken record by calling metadata again. But I think with respect to governance, there are three areas. For existing data sets, especially with respect to finance or PII, there's several access control areas in the industry that have been working well. However, as new domains start popping up, an example with like live or other areas with Netflix there, how do we make sure that as we scale data sets, the governance scales with it? I think that's where the biggest challenge is. So instead of just putting access control over it and having some manual curation of it, can we draw some semantics? In fact, using LLMs on the metadata itself to say, we anticipate these are the people who can possibly use it, or these are the business who can use it. Can we put down some lockdown or governance policies on top of it, and then ensure that only those people have access to it? This includes like auditing, compliance, legal. The second part of that is the lineage aspect. So lineage back in the day was like visualization of where it's getting used. Now it's gotten even more critical. If you want to retire data sets, if you want to retire like models that are not getting used, you want to understand that nobody's actually using it, you're sure. There's no way of knowing it. I can't ping up like a very large company with everyone on Slack and say, does anyone use it? So you have to rely on lineage and some metadata on top of that to be actually able to get there. One counterpoint to what Deepak was saying was in data land it's the other way, which is by default restrict access unless actually needed. So the AI data battle in that area will be, what is that nice line to navigate so that we don't stop practitioners from pushing things out while not getting into other problems of exposing data set that we shouldn't be. I think LLMs can help a lot too in getting there.
I think it's interesting that I think, we are all very bullish about using AI to help data management. We're seeing definitely some promising signs that that can happen. But especially when it comes to things like restricting access, or things that are a lot more deterministic. There's a lot more right versus wrong when it comes to that. And when agents themselves are non-deterministic, I think there is a host of problems and challenges that have to be solved there.
Yeah, I think like with some of the openness in terms of, let's say we have MCP for data sources, I am getting a sense that now governance will move into that area. I don't think that has been discussed well enough yet, but governance will move into, do I even have access to these data sources first, where I'll be able to extract data, and then the conversation continues from there. But for all of these, we need still a very foundational layer of saying these are the key data sets and these are the key metadata that I'm going to tag with.
Cool. I think that was all the scheduled programming we had. So it's time to actually turn it over to you all and see if we have any questions up on the board. If not, but feel free to either ask for a mic or just put up a question. Yes, Sandeep.
Awesome. I'm Sandeep from Intuit. Thanks for a very engaging conversation. The question I had is, with AI coming in, there is this term called the semantic data layer, right? And in some sense, I see a convergence between the metadata and the semantic data layer. So what I mean, just to give an example, is when you think of text to SQL and you're trying to ask information, when you see hallucination happening, it's because at the data layer, you actually don't know the definition of the term. So if I say, find me churn, LLM will hallucinate unless it finds, but here's the catch. At the table level, there is no mechanics when you think about the matrix and features. These are separate systems. So I think going back, there was a conversation which is, what is metadata? And there was this element on the business metadata. Isn't business metadata extended becomes the semantic layer? I'd be curious about your thinking around this.
Yes, I think with specific example in mind is a problem that I've dealt with recent times, not with the hallucination side, but generally there. We'll have like a cold start problem there, specifically with respect to, let's say, churn data or whatnot, where you would have a certain set of data sets that is certified as good. And those tags become metadata tags. An example being, give me XYZ data related to this domain of like watching or what did you watch or whatnot. Non-sensitive data, but you can timestamp, or you can clearly classify that and timestamp that in certain way of saying that this has been vetted. We know this pipeline works and this data set is accessible in a certain way for certain folks. And we know the quality of that is guaranteed. And we add a flag now saying this has now been certified very well by a set of teams who have actually worked on this. Now that becomes an input context for the LLM to be used heavily on. So back in the day, if you were to use like data warehouse, you will call it like a hint. Like the database query layer will say, you can send Oracle or like MySQL a hint and say, use this. That's the way in which at least I'm thinking about going in with, but more AI specific versions.
No, I think this is, this is an age old problem. The Pinterest example I was giving you was similar, right? Like, but in general, there are terms like that, churn, and then there'll be multiple teams, like call them data marts, right? Department 1 has a different definition of term. Department 2 has a different definition of term. So, and when you're asking a question like that, the LLM has to contextualize what the question is. So this is where I think a fine-tuned LLM based on the organization has to be taught, right? What some of these semantic, and that's where the semantics comes in, right? Like, if it's a deterministic definition available in one place, source of truth, the LLMs should be able to get it very easily. But the place where LLMs will shine is these ambiguous terms. And so how do you train your LLM where, like, okay, I mean churn as in the marketing department. Like if you give that in the prompt, it should be able to figure out what you mean, and it should get the right table for the marketing data mart. and then give you the answer versus go to the sales department and do it for you. So there has to be still some work done, but given the LLM and given we don't need to be as structured as we had to be in the past, I think there is more hope to solve this problem better than what we've done in so many years before.
I mean, like I was saying, when I was at LinkedIn, our data and our metadata was extremely structured. We had a data model review committee, for crying out loud. Is it still there? No. Okay. So,
thank God.
like
there are other committees, but at least not that one.
Okay. So, well, nowadays at DataHub, I nowadays think we should have a data model review committee internally. I kind of long for those days where fields were named exactly like they should be named and conventions were followed and foreign keys actually lined up. But as a deployer of tools nowadays, we encounter so many kinds of companies. We encounter companies who say we've got a glossary and it's got 50,000 terms, and we go, wow, you're mature. And then we encounter companies who say, we have 4 data engineers. What glossary? What is a glossary? And what is interesting is what we found is that there is a gold mine actually of business context, which does not require you to write or create business terms. And that lives in all of the human-generated, human-written text at your company. Where is that? Usually in the query logs, like a bunch of queries. BI tools have actually accidentally kept reinventing semantic layers. Whether you go to Tableau or Power BI or Looker, they all have their own little language that they've tried to use to come up with some semantics. And usually the folks that are, unlike the people deploying tables to production, the people who are writing code to transform those tables use good judgment. They will name things as revenue by year, or sure, there might be many revenue by year queries, but at least it'll be named revenue by year. So where we have found a lot of promise is instead of first waiting for a massive business glossary to get updated or uploaded, just go through all of the conversations that have happened on Slack or whatever, go through all of the text that lives in all of the queries that already exist. There's so much in code also that exists in a lot of companies. And then essentially vectorize it. And that then gives you a treasure trove of things that the LLM can go after as that first query, so that it gets closer to the space of terms and columns that it can then go access. And that's in many ways has kind of solved a lot of cold start problems. Some companies have also talked about essentially using that first step to first create the semantic layer. So imagine, 1 week into your deployment of a tool like this, you get a proposal for what the semantic layer should be based on all of the context that has been traveled. And once you approve that, then the linkages start autonomously forming, and then you start getting that. So I think there are solutions to the cold start problem, as long as you have access to a lot of unstructured data that lives in places that you normally don't think to look. I'm seeing some concerned looks from Jen. How are we doing on time? Okay, can we take another question? All right. Okay. We can maybe keep one mic here. We can just keep one.
My question is almost same to the third question over there. How is the AI changing this landscape? For example, you gave a example in that company name, I forgot, the Rectified or something, where an agent is asking how is my lineage, where is this table there, etc. So now with all the AI tools like Cursor and other things, it is able to read the entire repository, build the lineage, and actually identify where your data comes from, all the way from the Kafka and other things. So in my question is simple. On one side, I feel that data is very important to build or train any AI model. On the second side, all this data governance, metadata management, data discoverability, everything AI can do it. It may not be today, in future. So what do you think will happen to this whole area? Are we still using tools, or will AI be the one-stop shop for asking all the questions?
I think we'll still be using tools, but it will be AI based tools. Like that is my short answer, right? So all the tooling that you're talking about, it would be like the Goose example is a good one, right? Like, so these tools would be all based on AI solutions, but it would not be, most of the other tools would go away, right? It would be all based on AI, because as we talked about, the metadata layer is going to become more and more unstructured. And so when you're computing things on unstructured data, the only game in town would be AI, right? So all the tools would be based on that foundation, right? So I still think we'll need tools, because without tools it's very hard to govern, but they would be all AI based primarily.
So at least one way in which I think about metadata is, I guess there are two kinds of metadata. Metadata that does not exist, or metadata that can be derived from the data, and metadata that exists in isolation. For example, I can look at a Parquet file and then extract out what the schema is. I don't necessarily need a separate file telling me what the schema of this Parquet file is. Or if I want to figure out what is the column distribution for this set of files, I can read all the data and then kind of generate that profile. But then there are other kinds of metadata that are only known by the person or agent that created the data, and it's not found in the data. And in those scenarios, you will need, so there are two kinds of metadata. Metadata that can be derived from data, and metadata that cannot be derived from data and therefore has to be recorded somewhere else. And it is data, but it has to be recorded somewhere else. And so when I think about the metadata layer of the future, it is actually in many ways the base semantic layer for data. Here's a table. Here's how it's structured. Here's who created it. And that information is important in its own right and cannot be regenerated on demand. And so we will continue to need something that can be the repository of that metadata. How it gets created, how it gets maintained, as Deepak was saying, it's going to be very much AI driven. And humans are going to be 1 or 2 hops away from the metadata. Right now they are 1 hop away from metadata. They go into the UI, click a button, start typing out documentation, and very soon there'll be multiple hops away from the metadata. A business user will say, hey, go create me a churn report. But they won't tell it to their data engineer. They'll tell it to an agent. Then the agent will go, and the agent will be a BizOps agent maybe, right? And that agent will go talk to another agent, an agent that has been trained on writing good production data pipelines. That agent is going to go write that production pipeline. Maybe a human will take a look at it. Then as the production pipeline goes into production, and then it reports back. So there will be intermediaries between humans and metadata. But at the end of the day, the state that we need to keep that records what happened, how is this thing defined, what does it mean, that problem doesn't go away. In fact, maybe it becomes even more important.
You covered pretty much most of it. One part I'll say is, back in the day, at least, data engineers were primarily using humans as the endpoint of it. So updating the metadata was not a big deal. Going forward, they'll keep agent as a first-class citizen, which means almost all the metadata will be expected to be kept at fresh. Of when was it refresh, who was owning it, what happens, is there a primary, secondary owner? Just like how software or ML has observability and incident management with respect to data, the same will start applying to metadata pretty soon, because AI is now a first-class citizen. That's the main shift I'm saying. This is just programming to another engineer who's writing a pipeline.
Okay, one more closing. It must be a fun one. No, just kidding. No pressure. There's one in the back. Yes.
So my question is not necessarily on where data lives or where the querying happens. What do you guys think about where these models should be hosted, which processes this data? Do you have a stance if they have to be in cloud or on-prem or like AI data factories? Want to know, like, We put all the governance at databases, we put all the governance at queries, but once it goes to model, it goes to the model. How you emit all the logs, traces that goes in and outside the model, what's your stance on that?
That's a great question. So basically, for database people, this is a question about storage and compute. And are they close together or far away from each other?
I think it's going to vary by company and company. It's an easy answer, or that's what I'm about to say. I've done both models of deployment. Cloud mode has its own advantages of getting in, but on-prem will have I would say, a security and governance guarantee of worst case you get your footprint wrong in terms of judging a data set or a model, it still doesn't leave your network. So the bare minimum entry point when it comes to the level of observability or the caution that you need to take when deploying cloud will go high. But in general, I'm a fan of cloud deployment. That's just my personal preference.
Yeah, I think cloud I would also prefer. One thing I want to point out, just to add to what Nitin said, I think there is also governance and compliance that we are going to have on AI coming soon, the AI Act. So this becomes keeping metadata on models, model cards, how the model was created, what data was it using. Then again, when you're building an AI model, there are layers. There is model A feeding model B feeding model C. So you start seeing the same pattern that we are seeing when we are managing data. So all of this knowledge would have to be replicated for the model management as well. If and especially as we go to the world of agents, right? I mean, the traceability and lineage and governance, because the last thing you want is agents that are not trusted, right? And so in fact this will when we are asking what happens to the whole area, I think this is so this is where I want to come back to the first thing I said, like model is data, right? So data is changing in its form, but the governance layer is also evolving because the type of data is changing. So we start thinking of every model as data, then I think we start solving the problem that is going to be ahead of us.
Cool. So, I mean, I think we've already heard a few perspectives here. What we see in practice is anytime there are guardrails that, not all use cases are the same. If it is, something that is not very sensitive and your company doesn't have a huge problem in calling an OpenAI or a Anthropic endpoint to get back a suggestion for a term that you're about to create, maybe that's okay. But if it's about actually sending all your financial transactions so that it can summarize it for you, maybe not. So I think it all, unfortunately, it's context matters. And so the classification of the data itself that you're sending over and the use case that you're using to have that interaction with a model should really determine. I actually don't think of it very differently than service calling. I think, this duality between data and code has been always there. You can think of a model as data. You can also think of it as a function that you're calling over a network. And so you can basically go back to thinking, based on my company security posture, am I allowed to call this function over the network outside? What are the input parameters? What are the output parameters? Is this data okay for me to send? And if you think of it that way, then it kind of simplifies things quite a bit in terms of just think of it like a microservice call that's just going outside your network. That's right. Yeah. I do think that there will be a healthy tension in the industry over the next year or two between fine-tuning models and distilling models and running them on-prem versus, and I think the cloud players like the OpenAIs and the Anthropics of the world are going to obviously want to counter that by basically allowing for fine-tuning and training and guardrails within their premises. When Snowflake first came out, the database industry said, no way, we're never going to have, our crown jewels of data in the cloud. And we are fortunate enough to work with like Fortune 10 companies, and many of them say, "Oh, DataHub, you have to be on-prem." And they're like, "But you're using Snowflake." But it's true. But I think Snowflake successfully disrupted that by proving that they were managing data responsibly, etc. And I think a lot of these AI providers are going to do something similar. And once you build trust and you can retain that trust through accurate audit logs and etc., then I think the industry faster and mostly cheaper is always better, right? So we'll all, as long as security is maintained. So maybe we're good. Okay. Do we have a winner on the?
Not yet. We're still waiting for more engagement. But thank you to our panelists for engaging conversation, and thank you all for your questions.